That's the right answer.
Yep. Garbage bag, trash can.
Totally. I don't know. Not mine. Yeah. Okay. So speaking of sledding, if we go sledding and I take Max, I will be sure to give you that picture. How many of you were able to get this figure? Okay, and if you weren't able to get the figure, make sure you're turning to one of these volunteers who raised their hand to help you. What we're going to do next is just save this figure. So this is pretty nice. I don't know. What are some other things you could do? Any ideas?
Change the color.
So we could change some colors. Yeah. And if you copied my code, then you got some colors. Is it Maddox?
Yes.
So Maddox is saying, let's add some color. Personally, I find color really nice in figures. I think it is good for attention. You may have seen this option in the count plot called hue. You see this type. There's a way to turn this off in the settings if you like. This is just an AI option for you. We'll talk about AI in a second, but often the AI options are very helpful, and often they are not. So you have to kind of know which is which is part of the challenge of getting set up. So I'm just going to create a hue, and I want each state to have a different color. So I'm going to say, give it a hue based on its state. So all I'm going to say is hue is equal to, and then I'll just say state. And this makes it so that the code knows to apply a different hue by state. So why isn't this colored? I have to rerun it. So I'm going to hit rerun, and I get a bunch of new colors. Okay, any questions? Yeah.
Is there any way to change these colors for user?
Yes, there is. It's a little more, it's like a more advanced skill. But yeah, there's a way to do it. If you wanted to talk about it after class, we can do that. But I think it's a skill we'll get to maybe near the end of the semester for some of the more nuanced things. Yeah. Any other questions here? Yeah, I don't love these colors, but they're fine. They're better. Okay, so nice. I think this one line is much nicer than going through all the click steps in Excel. We can also do this exactly the same way every time. Okay, so a couple of ways to save our figures. The way I want to show you is you just right click on this, click Save Image As, and then we'll call this exercise 1, 1, whoops. And that saves it to my downloads folder. Exercise 1, 1. We'll replace it, and that goes to my downloads folder, and we get this. This may seem like a trivial thing to download a figure and then work with it, or like have it as an image file. I'm going to keep prompting you to do this in your homework. After like this week, basically, I'm not going to accept screenshots. I want the actual image file as your submission. The reason this matters, it's not going to matter so much at the beginning of the semester. In fact, like, I can probably barely distinguish between this and a screenshot. But the reason it matters, later in the semester, you're going to be working with your own figures. You don't care about this one. Like, this doesn't matter to anybody. But you're going to create a figure that will matter to you. And having it in its full form, not just the screenshot, is going to be really good for your presentations and your paper. You can get away with working with screenshots, but this is best practice. Okay, any questions? Nice. All right. Look at this cute baby. Okay, so this is exercise 1.1 done in Python. We're going to spend a second. So I've walked you through all the steps, but I want to take some of the training wheels off and have you create your own figure of dataset 2, which is this employment status. So we're going to spend like 3 to 5 minutes working through visualizing this second dataset. You're going to sit down, chat with the people around you, figure out what the data structure is, what the variable type is, and then a best practice for doing the data visualization. So a bunch of steps, and we're gonna do them together. Once you get through this, once you try a few things, get stuck, figure out how to get unstuck, then we're gonna do it all together on screen. Okay, so we'll take about 3 to 5 minutes, and we'll go from there. Make sure you're chatting with the people around you. Go.
It's really close. Oh yeah, maybe not. The last 2 years for me has just been like C. It's been more than 2 months. He's rough. I really am good at
What if we switch this class to only C?
as like that, you know, like Python, yeah.
Yeah. There is Python, which is like a way of using C code to write Python functions. Have you used
I use
Python?
I just added another.
Okay.
Oh, you
Chris.
My brain's all over the place. Appreciate it. Yeah, the only thing is the syntax for
Yes.
like the line of syntax. Oh, yeah, like for each. It's just like the code. It's just like the code.
No, that's
man.
but it's out of 100.
The brackets make it So then graph that stage
Or never mind, let's not do it.
Yeah, I read the documentation. Like, if you do stat, you make percent proportion of probability. Yeah, so basically you just do comma stat, and you do equal any of it.
All right. If you're still working, that's great. How many of you were able to create a nice visualization, or at least a visualization? Hands up. Nice. And the rest of you were not. That's also acceptable. We're going to walk through this together. You're going to tell me where you got stuck, and then I'm going to bail you out. So the first thing we're going to do is just load this data set. So I've already given you the code. I've told you where it is and what it's called. So we're just going to run status. Now, if I were just loading this data, I would not know how to visualize it. Like, I don't know what's inside of it. So the first thing I'm going to do is just print the data. I want to see what it looks like. And we can either do this with just by writing status, which gives us the whole data set with these ellipses to tell us that there's a lot of data here. Or I can just get the header. So this is just to get the header. So the first 5 rows. So here I know, first off, I have an index variable. So hands for cross-section. Hands for time series. Hands for panel. Cross-section is right. We have 1 row for each household. And then we have a second column which represents employment status. And that's the one I want to try to summarize. So maybe a first thing to do is let's just status, and then we can do value counts. If I do this, it's going to give me a value count for every household and employment status. And that's not what I want, actually. I want a value count for just employment status. So what I'm going to do is just select the row for employment status, and then just perform a value count on that single row. The syntax for selecting a single row looks like this. I have status, so the data set, but then I just want a single row from that data set. So I'm going to put these square brackets, and then we're going to put inside status some variable. AI is wrong here. I want the variable called employment status. So I'm just going to copy this, put it inside, and this is going to just give me the single row. So this is how we select single rows, and then I just want value counts, and it's going to give me a nice little summary table. Any questions about this? What would happen if we got rid of these parentheses? Well, oh yeah, Erwin. So yeah, we're going to get an error. It's saying invalid syntax. What's happening here is Python doesn't know, Python looks at this and thinks it's a variable because there's no parentheses around it. It doesn't treat it as text. It treats it as a variable. So I'm just going to put the parentheses back around it. So now it knows that this is a name of something. It's like some text, and it knows where to look. Okay, any questions about that? So then next, we want to create a visualization for this. And as I'll prompt you over the next 6 weeks, we want to write some Seaborn. So we're going to create a visualization using Seaborn. Here, so we just want Seaborn. Here, it's a binary categorical variable. What are some ideas for visualization types for binary categorical data? I mean, there's basically 2. Yeah.
A bar chart would be the easiest, we already done it, but a pie chart would also work.
So I think in this case, we actually have 2 that can work. We can either use a bar chart, which is the standard one, or we could use a pie chart. I think this is the one case where a pie chart can work. But let me just caution you about pie charts. We're going to use a bar chart. Let me caution you about pie charts. Pie charts are so frowned upon that the Seaborn package doesn't even include one. Let me show you. I just Googled Seaborn pie chart. Seaborn doesn't have a direct pie chart. Pie charts are so frowned upon, it's not even included in the Seaborn package. You can do it in Python, you just need to use a different package. So we're going to use a bar chart. Anyone remember how to write a bar chart? Like, what's the next thing? SNS dot what? Yeah. Count plot. Okay. And then someone want to tell me what's next? Yeah.
Data equals status.
Data equals status. Or we can just get rid of the data is equal. And then how would, what's maybe a next step we would go about here? Yeah. X equals employment status. I'm going to run this. So here we have two bars, each representing the counts associated with these two categories for this particular column. So this X is telling us, first, we want this on the horizontal axis. We want the categories to be on the horizontal axis. And then we want the counts to be on the other axis. And so we get our bar chart. Any other additions here? What if we wanted the columns to be different colors? Hue. So let's just write hue is equal to employment. So we have two different colors. Sometimes this is helpful for just distinguishing between them. You could also switch the axis just by switching X to Y. This is my personal favorite for most things, a horizontal bar chart, especially when text gets long and we have many categories. But I think a horizontal bar chart is, or a vertical bar chart is basically just as good. Okay, and then if we wanted to save this, we just right-click, save as, and then we can say exercise 1 data set 2. Okay. I just like keeping a picture of Maxine up all class. Hope you don't mind. Effective use of projector. Any questions here? So homework 1.1 asks you to do this kind of thing, just creating a visual summary of the data. So this is just some practice in class, and then you're going to go home, take the training wheels even further off, and do this on your own. I want to show you one thing before we move on to part 1.2, which is using AI. Have you heard of AI? No? Okay, me either. I'm sorry, that's the same joke I've said every class all semester. And I'll say it again next class. So we live in a world of wonders. We have generative AI, which can be very helpful in writing code. I use it to write so much of my code. It's a tool we didn't have 3 years ago. The process we would go through years ago was, if we had a question about code, we'd either go to the documentation, which is on the internet associated with the software you're using, or you go to a website, like a forum website, where people would just ask questions about code, and then other people would offer help. So you go to those kinds of websites, usually through Google. But now we have pretty good tools for helping us write code and fix our code. So I just want to show you some of the basics. one of the nice things about Google Colab is that we have Google Gemini built into the notebook. So let me just show you some ways of using AI. So let's say I wanted to create a count plot of this data set. I've already created some summaries here of status. But let's say I just wanted to create a count plot from scratch. So I'm going to write this hashtag. This is just a comment. This tells Python to not run this, that this is just for the human to read, which in this case is me. So I'm just going to say create a count plot of employment status in the dataset status. And so let's check this. So I've given it some English, and what Gemini does is translate the English into Python. That's one of the ways you can think about what AIs are good at, is doing a English to Python translation. And what you can see here is it does something very similar to what we did. So it says sns.countplot gives status. I'm not sure you can, if you're in the back, I'm not sure you can read that. X employment status, and then it gives it a color. So this is very similar to the kinds of things we did. I can, if I want this code, this gives me a code hint, so it's telling me what it thinks I might want in gray. If I hit tab, as I'll do here, so I hit tab, it auto-completes. So it just writes the code in that it thinks I want after I tell it that that's what I want. So I hit tab to just confirm that it's the code I want to write. And if I run this, I think this should work. So actually very similar to what we wrote. Gemini will not always get things right. So what I've seen from a lot of students is if you're early to writing Python, you think you can rely on AI to do most of the work, which in a lot of ways, we're in a world where AI can write a lot of your code. But often you'll run into a situation where Gemini also doesn't know what's going on and will not tell you that it doesn't understand. And often you'll run into error after error because the AI doesn't know what it's doing. So just some words of caution, like it's a great tool to use. I would not be doing you a service by telling you not to use it. I use it. Everyone who writes code uses AI these days. It's an incredibly powerful tool. Treat it like a knowledgeable but imperfect friend. It will help you in some cases, and it will also make mistakes. I wanted to show you an example of it making a mistake, but it didn't. It will make mistakes. It's made at least 3 mistakes for me today already. Also, when you're turning in your work has to be your own. This is not a new problem. As long as we've had classrooms, as a student, I would go to my friends for help with my work. My friends, who may be more knowledgeable than me, would give me input and guidance on how to do a homework or do an exercise or whatever it is. And I would use that. That's very helpful for learning. So AI is not fundamentally a new thing in the classroom, right? Like we have, it's new in some ways, but getting help is very valuable, and you should be using AI, or you can be using it. You can opt out if you wish. But when you turn in your work, make sure it's yours and not your friends. So same ideas apply. This is we're sort of in a gray, murky area. But just make sure the work you're turning in is yours and you know what you're turning in. That's my one rule for using AI in this class. If you have any questions about that, I think we've talked about it already, but I strongly encourage you both to work with your friends on your homework and to use AI to supplement your writing. Any questions about that? The other way you can use Gemini is with this button at the bottom. So you can just click on this, and then you can just chat with it directly in the notebook. So sometimes that's a more helpful tool, but generally when I'm writing code with AI, I'll just give it a comment in the notebook. This way is a little bit more involved. All right. Any questions? We've spent most of the class talking about the exercise from 1.1. I just want to tee up a bit where we're going next class. I posted homework 1.2, but we're going to move the due date till next week, so because we're not going to get through it today. Okay, so nice. So this is doing some data visualizations. This is all with categorical data. And remember what we're doing. We as economists, we build models of decision making, and we want to inform those models with ground truth. We want the data to tell us whether our models are right. We've just walked through summarizing categorical data, and as economists, most of what we deal with generally has some numerical component to it. So we're going to spend the rest of this class and a big part of next class talking about summarizing numerical variables and just walking through some of the basic best practices with this type of data. We're going to stay in cross-section. So like we had before, we have many entities at one point in time. So it's just one point in time, many unique identifiers. And then essentially the way of thinking about numerical variables is just that they're variables that we can do math with. With categorical data, you can't do math with employment status. You can do math with the number of employed people. So we went through and counted the number of employed people, which gave us a number. So we can do transformations that turn categorical data into numerical values, but when we're dealing, but that's a transformation. We can deal directly with the numerical variables. So the main questions we're going to try to answer when we deal with single numerical variables is just essentially, what is the data? What does the variable look like? What's the distribution of values? You've all seen histograms before. And you've probably all seen box plots. How many of you have created a histogram? Okay, and how many of you have created a box plot? Nice. Yeah, maybe box plots are the more common one. I'm going to show you one improvement on the box plot. But we're going to start with the histogram. So essentially, the histogram is, I would say, best for variables when we have a long list of numbers. So when we have lots and lots of data, we want to understand the distribution. We'll talk about a histogram in a second, but I think that's the best application, which gives us the shape of the distribution. When we have fewer observations, we can still use a histogram, but sometimes we want something slightly different. So we want to know quartiles of the data. And maybe individual values as well. That's where we'll use the box plot plus sort of its pairing, what we call a strip plot. So we're going to pair these things together and call it a box and strip plot. This is good for fewer observations. It doesn't work as well when we have many observations, but we'll come to that. So like we did last class, I just want to ask some questions of you. I know this is the end of class. We're already an hour in. But I still want to ask you some questions about best practices here, like how we read these figures and where your eye goes. So let me just ask you some questions. First question, which age group has the most Starbucks customers? And what I've set up here is a histogram. This ages are a numerical variable. So you've seen age on the horizontal axis. And all I'm doing here is just taking this numerical variable and binning it. So I've created categories on the real number line. And then just like a bar chart, we're just going to go through each of the bins and count up the number of observations we have in each one of the bins. And then on the vertical axis, somewhat controversially, I'm not including an axis label. Some of you will object to this this semester, but I prefer not including a count on the vertical axis. So these are just counts on the vertical axis, and then the bins on the horizontal axis. All right, so someone want to make a case for which age group has the most Starbucks customers? Yeah. 40 to 55. Remind me of your name. I'm sorry.
Bridget.
Bridget. So Bridget's saying 40 to 55. Yeah, Casey.
You're unevenly distributed.
Okay, so Casey's looking at the horizontal axis and saying the bins are not of equal size, essentially. Is that right?
Yes.
So Casey's saying bins are not of equal size. Someone want to add some detail to this? What's the issue? Yeah.
The age range isn't the same for each section.
So age range is not the same, and how do we see that it's not the same? Yeah. Yeah. So 3 different ways of, I think, saying the same thing here, right? Remind me of your name. Ira. So Ira's saying same as Casey and Maddox. Maddox, right? So here, 35 to 39, that's just 5 different years. 40 to 45 is 15, or something like that, right? So we have differently sized bins, which makes it look like the 40 to 45 age group is much larger than the 30 to 39 age group. So this is one of the principles with histograms, and visualization in general. I can trick you into thinking something that isn't true. I can use a visualization to mislead you. I have a whole book in my office, if you're interested, called How Charts Lie, which sort of talks about ways of deceiving, so that we don't do it. This is just one of those ways. If I were to truly represent the horizontal axis correctly, it would look like this. So I've squished this one and then spread this one out. Okay, any questions here? First principle. It's actually very easy to do in code. Use equal size bins. Okay, so we're gonna use equal size bins. How would we, and maybe this is too easy a question for this room, how would we distinguish between a 55-year-old, if we were interested in understanding the difference in customers between the 55 age group and the 60 age group, how would we do that? Can we tell from this figure, and then if we can't, what would we do? Maddox.
You can't tell, and you would just make the bins 5 years instead of 7 years.
Okay, so first off, we can't tell because we put both the 55-year-old and the 60-year-old in the same bin. What we can do is create different bin sizes. So that's what we're going to do. Instead of using a decade as the bin size, we're going to use 5 years, which makes it a little bit easier to distinguish. So we have a 50 to 55, and then we have 55 to 60. And then we can just go through and count how many customers are in each one of these 5-year age gaps. Any questions here? What if I took this further? So let's say I wanted to specifically distinguish between a 44-year-old and a 45-year-old.
You could shift the bins, so instead of being like 15, 20, 25, it could start at like 16, 21, 25, and then it would eventually be like, or I guess you'd shift it to the left, and then it would be, they'd be two distinct bins.
Yeah, that's very interesting. Remind me of your name.
Ryan.
So Ryan's saying one thing we could do is just shift the bins so that the bins sort of sit on either side of 44 and 45. So 44 would be one bin, one 5-year bin, and then 45 would be in the other. This is one way we could maybe try to split these two ages. There's another way, which is maybe a more standard way.
Just create one for 43 years old, 45 years.
So we could create bins specifically for 44 and 45. And we can actually do this for every year. So instead of using 5-year age groups, let's just use 1-year age group. Y'all have predictions about how this is going to look? Think about this. We're going to set up bins for every year, and then we're going to plot this as a histogram. I want you to turn to someone next to you. Make a commitment. What do you think this is going to look like?
Everything's gonna be squished together. Yeah, like you can really actually exactly what it's like. Oh, okay. So like it's like a dot set.
It also depends where your number is.
Okay, love the conversation. We're almost near the end of class, and I want to give you some stuff before we go. Look at this. Oh, my figure didn't upload. This is supposed to be here, highlighting. So my apologies. 10 lecture points for me for a bad figure. So this is what it looks like. How many of you like this? Hands up. How many of you don't like this? Correct. Someone tell me why. Ryan.
If you were to put out all the labels to label all the ages, you wouldn't be able to read it. Like even with 44 and 45, you wouldn't really read which.
Okay, so labeling is bad here for a couple of reasons. One, my 44 and 45 sit directly on, like basically directly on top of each other. If we're to do that for every age, that would not be great. One thing we could do to fix that problem is just index like 5-year increments, and that's something we could do. So we could fix that problem. What's another problem with the figure? Yeah, AJ. So yeah, there's the bars are so thin it's hard to kind of see what's going on. Any other ideas here? Yeah, right.
You really don't care about the rest of the data because the question is 44 versus 45, so all the other data is like.
Okay, so one thing we could do is just eliminate all the other data. Yeah. Maddox.
It's messy. Usually for like things like this, you want a bell curve, and you don't really have that like this because the constant up and down nature of it.
I think this is the biggest problem with this figure, is we have so many bins. The data itself is noisy. The difference between any two bins that are right next to each other, including 44 and 45. These two are identical, but the ones I meant to label, 44 and 45, are very different. They're right next to each other and very different. Because these bars move around so much, we don't know if the difference between 44 and 45 is real or if it's just noise. You can see so much noise, it's hard to know. Anyone know how we fix this problem? Someone other than Maddox? 10 lecture points for answering so many questions. Yeah, James.
Like you said earlier, we could create bigger indexes. We can just break down by 5. Another way you could, like he said earlier, you could just eliminate the rest of the data on the photo and branch accident.
So yeah, so we could focus on just the 2 years, and that would give us just those 2 years. I would still say with even focusing on just 2 years, we still don't know if the difference between those 2 years is random noise or meaningful. And you can see sort of part of the reason why. There's so much variation, so much noise between the bars. But the first element we could do, right? So we could increase the bin width to be 5 instead of 1. But then we can't see the difference between the 2 years specifically. Maddox?
Sample size.
Increase the sample size. So these are some of the approaches we can take. If we have a larger sample, we can just increase the sample size. And I want to show you what that looks like. So we could go from this thing to this. I've now, I think I went from 500 to a couple thousand. And here, there's still some noise, but the noise is much smaller. So you can see 44 and 45 are now closer together than they were before. Any questions here? So when you're creating your histograms, these are the things to keep in mind. You want equal size bins, you want to balance resolution, so how tight the thing is, against the statistical noise in the data. There's no hard and fast rules for this, but these are the things to be thinking about. So you can play around with these as you're creating your figures. The last two things I just want to mention, you've all seen statistics before. I just want to mention it here. We have mean, which is just a measure of the central location of the data, and then we have standard deviation, which is the spread. So essentially the average. It's not exactly the average distance from the mean, but it's pretty close. We're going to talk about some of the mathematical nuances here in part 3. Okay, again, I'm in the hole. Another negative 10 lecture points. This was supposed to have mean and standard deviation on top of it. They'll be updated on the website when that goes up. But the mean is just sort of the middle point of the data, and then the standard deviation is just a measure of how spread out the data is. So if there's lots of spread, the standard deviation will be large, and if there's not that much spread, the standard deviation will be small. You've all seen these things before. We're going to actually calculate this stuff in our exercise, which I don't think we want to do today. Casey agrees. Okay, so here's a bit of a summary. Use histograms as a way of summarizing numerical variables, particularly when we have lots of data and we want to understand the distribution. Use histograms with equal size bins. The code will do this for you. At least Python will. I think Excel is a little bit funnier. And then balance statistical noise against resolution so that you can see as much as you can, but sort of hiding the noise. Here's the outline of what we just did. We selected all Starbucks customers. The transformation we did is we went through, we constructed bins, and then we counted in each one of the bins. So it's sort of a two-step. We constructed the bins, and then we counted in each one of the bins. Histogram software will do those steps for you, but you need to know that it's doing them. And then the encoding we did is we had for each one of the bins, we put that on the horizontal just like a bar chart, and then we counted the height of the bin. Okay, we're going to do exercise 1.2 at the beginning of class next time. Homework 1.1 is due tomorrow. You don't have to upload exercise 1.2 today. We'll do that next time. Homework 1.2 is due next week. See y'all on Tuesday if snow permits. We'll see how things go. Go sledding.
Yeah.